We're discussing quadratic graphs. This is included in IGCSE syllabus as well as GCE syllabus. Alright, so before starting with quadratic graphs, let's quickly revise what are linear graph. So linear equation is y is equals to mx plus c, the general form of a linear equation, where m is the slope and c is the y-intercept. So for an equation 4 is y is equals to 4x plus 3, the slope will be 4 and the y-intercept would be 3. Now when the slope is positive, the line is supposed to look like this. When the slope is negative, the line is supposed to look like this. It will be a falling line. If the value of m is undefined or infinity, then the slope will look like this, undefined slope. And if the slope is 0, then the line will look like this. So to plot this particular line, you will make a table. You will take any three values of x. Let's say I'll take 0, 1 and 2. Then we'll get three corresponding values of y. The first one will be 3, the second will be 7, and the third will be 11, and so on. Then you'll plot these 3 points on a graph and then join the 3 points with a ruler, and you'll notice that this line will be cutting the y-axis at 3, and it will be a rising line because the slope is 4, which is positive. So that's all about linear graph. Let's quickly do one question related to linear graph before we jump to quadratic graphs. This is the first question of the worksheet. I'll attach the link to the worksheet in the description as well. Okay, so question number 1, state which of the figures below could be the graph of part A, y is equals to minus x minus 1. So for y is equals to minus x minus 1, the slope is negative 1. Slope is always the coefficient of x, and the y-intercept or c is also minus 1, which is this constant. So our graph should be a falling graph, and it should cut the y-axis at minus 1. So it should look something like this. Now which of these 6 graphs look like this? It is figure number 2, I believe. Yes, it's a falling line which is touching the y-axis somewhere around minus 1. So the first answer is 2. Part B, y is equals to minus x. Now the slope is minus 1 and the y-intercept is 0. So it should be a falling line which should touch the y-axis at 0. So it should be figure 6, a falling line which touches the y-axis at 0. Okay. Part C, y is equals to x plus 3. So the slope is 1 and the y-intercept is 3. So it should be a rising line which cuts the y-axis at 3. So that would be figure 3. It's a rising line and it's cutting the y-axis somewhere over here at 3. Okay. Then we have y is equals to x. The slope is 1 and c is again 0. So a rising line that cuts y-axis at 0. So this is the line. So the answer for part D is 1. Then we have y is equals to minus x plus 3. So it should be a falling line since slope is negative 1 and the y-intercept is 3. So falling line that touches the y-axis at 3. So that should be figure a falling line that touches the y-axis at plus 3. So it will be figure 4. Yes, this one. It is a falling line and it's touching the y-axis at +3. And then part F is y is equals to x minus 1. X minus 1. So again the slope is +1 and c is -1. So a rising line which touches the x-axis at -1, so that is figure number 5. Okay, coming to the quadratic graphs. For an equation, quadratic equation y for a quadratic equation y is equals to x square, the graph is supposed to look like this. It will be a U-shaped graph. For a graph for the equation y is equals to minus x square, the graph is supposed to look like this. It's an inverted U graph. And if the equation is y is equals to x square, let's say -3, the same graph will go 3 places down, 3 units down. So now it will cut the y-axis at -3. So this -3 is actually the y-intercept where the graph will cut the y-axis. Here it was 0. So the graph was cutting the y-axis at 0, right? So now if I change the equation to y is equals to minus x square, let's say +2. Now this same graph will go +2 units up. So it will still look like an inverted U, but it will cut the y-axis at 2. Now let's go to the worksheet question. Okay, so question number 2. State which of the figures below could be the graph of part A, y is equals to minus x square plus 4. So minus x square means the graph will be in inverted U shape, and plus 4 means it will be cutting the y-axis at 4. So this will be figure number 2. Part B, y is equals to x square, so that will simply be figure number 1 like we just discussed. Next, part C is y is equals to -2 plus x square. Now plus x square means it will be a U-shaped graph, and -2 means that this U shape will be cutting the y-axis at -2. So that will be figure number 4, a U-shaped graph which is cutting the y-axis at -2. So 4, figure 4. Okay. Part D, minus x square minus 2. Minus x square means inverted U graph which will be touching the y-axis at -2. So inverted U which touches the y-axis at -2. So that's figure 5. Next is x square plus 4. So U-shaped and 4 units up. So figure 6. And then minus x square is simply figure 3. Okay, so the next type of graph would be of the form y is equals to, let's say, x minus 3 whole square. Previously we just discussed the graph of shapes like y is equals to x square plus 3. Here the 3 is outside of the whole square. So the graph, let's quickly revise, it will be U-shaped graph which cuts the y-axis at 3. But here the -3 is inside the whole square. So what happens now, you simply substitute x minus 3 is equals to 0, which gives us x is equals to 3. So the graph will simply be a graph like this which cuts the x-axis at 3. Now this -3 inside the whole square will move the graph 3 units to the right. Previously the 3 was moving the graph 3 units up or 3 units down if it were -3. Now when we write a number inside the whole square, this thing moves the graph either to the right side or to the left side, not up and down anymore. And if it's -4, it will move graph 4 units to the right on the x-axis. And if it were +4 whole square, it will move the graph 4 units to the left on the y-axis. So here. Okay. So a few more examples. Y is equals to, let's say, x plus 5 whole square. This will move the graph 5 units, to the left, not to the right. Because like we just discussed, you substitute x plus 5 is equals to 0. So the solution or the root of this equation is -5. So the graph shifts 5 units to the left. Similarly, for a graph like for x, let's say -8 whole square, this will move the graph 8 unit to the right. So it will look something like this. Also, if the equation is something, if the equation is, excuse me, yes, so if the equation is y is equals to -x, let's say +4 whole square. Now because of this minus, the equation will have a negative x square coefficient when we'll open the bracket. So that means now the shape will be an inverted U graph. So it will be something like this, and the rest working will be the same. When you substitute x plus 4 is equals to 0, we get x equals to -4. So the graph will be of inverted U shape, which will shift 4 units to the left. Rest will remain the same. Question number 3. State which of the figures below could be the graph of part A, x plus 1 whole square. So the figure will move 1 unit to the left. So it could be this graph or this graph. Which one to choose? Do we have any other equation like this? Yes, we also have part D. Look at part D, which is x plus 3 whole square. So this one will move the graph 3 units to the left. So the graph for this will be figure 3, since it's further to the left, and the graph of part A will be figure 2. Similarly for part B, it's x minus 3 whole square. So the graph will be moved 3 units to the right, so that would be figure 1. And then part C's graph will be moved 1 unit to the right, so that would be figure 4. Alright, next type of equation is when we have something like this: x plus 3 bracket x minus 2. So this is a quadratic equation. The coefficient of x square will be plus 1, because when you open this you will get x square minus 2x blah blah something something. So the coefficient is x square, so that means the graph will be a U-shaped graph. Now equate this is equals to 0, we'll get x equals to minus 3. Equate this to 0, we'll get x equals to 2. So the two solutions or the two roots are 2 and minus 3. So graph will be a U-shaped graph which will cut the x-axis at 2 and minus 3. Similarly, if we have an equation y is equals to, let's say, minus x plus 1 and x plus 2. So now the coefficient of x square will be negative x square. Open this, you will get negative x square, negative 2x plus x plus 2. And so it's a quadratic equation whose coefficient of x square is negative. So the graph will be an inverted U graph, right? And now let's look here. When we equate this to 0, minus x plus 1 is equals to 0. We get minus x is equals to minus 1, which gives us x is equals to 1. This is the first root, and the next root is, or the solution is, x is equals to -2. So the graph will be inverted U graph, and it will cut the x-axis at -2 and 1. So the graph will be something like this. Alright, now let's do the next worksheet question. Question number 4, which says state which of the figures below could be the graph of part A, x minus 1, x plus 3. So the solution will be x is equals to 1 and x is equals to -3, and the coefficient of x square is positive. So it will be a U-shaped graph which will cut the x-axis at -3 and 1. So I guess this is the graph for for part A. So this would be 1 and this would be -3. This would be -3. This is also a possibility, but here we have a bigger positive value and a smaller negative value, which is not the case for part A. Our positive value should be smaller, which is 1, and our negative value should be bigger, which is -3. So figure 1 is the answer for part A. Part B, for part B, the equation will open up to -x square. So it will be an inverted U graph, and the roots will be, one root will be x is equals to 4 and the other root will be x is equals to -1. So we're looking for an inverted U graph which cuts the x-axis at 4 and -1. So this would be it. This can't be it because it has a smaller positive value and a bigger negative value. Our positive value is bigger and the negative value is smaller, so figure 3 would be the answer. And then for part C, again it will be an inverted U graph because of -x square, and then the two roots are x is equals to -2 and then x is equals to 2. So an inverted U graph which cuts the x-axis at 2 and -2. So this would be it. So symmetrical graph, same weightage to the positive x-axis side and the negative x-axis side. So the answer for part C is 6. Alright, another type of quadratic equation is y is equal, or another form of quadratic equation, x minus 3 whole square, let's say plus 2. So the coefficient of x square is positive, so it will be a U-shaped graph. -3 will take the graph 3 units to the right, and +2 will take the graph 2 units up. So the graph would look like this. It will be cutting the it will be passing through the point 3, 2. Alright, this point is called the turning point, but we'll study this in detail the next year. Okay, what about the equation y is equals to x plus 5 whole square, let's say -3. So the +5 will move the graph 5 units to the left. So here -5. Now this graph will also move 3 units down because of the -3. So the graph will be something like this, cutting the passing through the point -5, -3. What if the graph is something like y is equals to -x plus 2 whole square plus 1. So because of the negative sign outside of the square, the coefficient of x square will be -x square. When you'll open this whole thing, you'll get an equation in the form of -x square, which means inverted U, and the rest would be the same. The root will be -2, x will be, when we equate this to 0, we'll get -2, and +1 will move the graph 1 unit up, and it will be an inverted U-shaped graph. So something like this, inverted U which will be passing through the point -2 and 1. Question number 5. State which of the figures below could be the graph of x minus 3 whole square minus 2. Now, x minus 3 whole square will take the graph 3 units to the right, and minus 2 will bring the graph 2 units down. So, 3 units to the right and 2 units down, so that will be figure 3. For part B, it's x plus 3 whole square, so the graph will go 3 units to the left and 2 units up. So figure number 2, 3 units to the left and 2 units up, so figure 2 simply. Question number 6. State which of the figures below could be the graph of part 1, equation minus x plus 5 whole square plus 1. Part 1, y is equals to minus x plus 5 whole square plus 1. Let me write it over here. Y is equals to minus x plus 5 whole square plus 1. The minus sign is outside of the bracket, so when we'll open this, we'll get minus x square, equation in the form of minus x square. So the shape of the graph will be inverted U. So it's either this or this. Now let's see which one of these two is it. So equate this to 0 and we get x is equals to minus 5. So the graph has to shift 5 units to the left and 1 unit up. So it is this one, figure C simply. So the answer for part 1 is figure C. Part 2 is y is equals to minus x minus 5 whole square plus 1. Again the negative sign is outside of the bracket, so it will be an inverted U graph again. It will move, when we equate this to 0, we get x equals to plus 5 and the graph will go 1 unit up, so it is figure B for part 2. For part 3, now part 3 and part 4 are slightly trickier. Part 3, minus x plus 5 whole square plus 1, y is equals to this. Apparently it looks like that the coefficient of x square is negative, but it's not. When we'll open this using the formula a square plus 2ab plus b square, or let's just rearrange to 5 it. Let's just rearrange it to 5 minus x whole square plus 1. Open this with a square minus 2ab plus b square. So we get a square minus 2ab plus b square plus 1. So notice the coefficient of x square is positive. So it will be a U-shaped graph. So a U-shaped graph that whose root will be, or whose values of x will be x minus x plus 5 is equals to 0. So x is equals to 5. So it will move 5 units to the right and then it will go 1 unit up. So that is figure D. And similarly for the last one, we have y is equals to minus x minus 5 whole square plus 1. Again, since the negative sign has the square on it, negative of x has a square on it, so it will become positive x square. So the graph will be a U-shaped graph. Equate this to 0, minus x minus 5 is equals to 0. So x is equals to minus 5. The graph will move 5 units to the left and then 1 unit up. So that is figure A for part 4. Here, the next question is, which of the figures shown below could be the graph of y is equals to x square plus 2? So that is simply a U-shaped graph that's moved 2 units up. So that's figure 3. Part B, the graph of x minus 2 bracket x plus 1. So the roots are simply x is equals to 2 and x is equals to minus 1. So that would be figure 2. It can't be figure 4, although they look a little alike, but here the negative value is bigger and the positive value is smaller. In our case is actually the opposite, so that's figure 2. And figure 3, for part C, the coefficient of x square is negative. So that means the graph will be inverted U. So we only have figure 1, which is an inverted U graph. So the answer for part C is simply figure 1. Question number 8. Okay, so the sketch shows the graph of y is equals to ax power n, where a and n are integers. Write down a possible value for a and a possible value for n. So this is actually a very straightforward question, although it looks a bit tricky in the start, but it's actually pretty simple. All you need to do is find a possible value of a. Now notice that the graph is inverted U shape, so a has to be a negative value. The coefficient of x will be negative, so use any negative value, write any negative value. I'm writing -1, -2, -3 would work as well, as long as it's an integer. Keep that in mind, right? So the next is write a possible value for n. So this is a quadratic graph, so the power of x has to be 2. The power can't be 1 because a linear graph looks like this. It can't be cube and so on because a cubic graph looks something like this, which you'll learn in grade 10. So the only possible answer for n is 2, and for a you can write any negative value. Question number 9. The variable x and y are connected by this equation. Some values of x and corresponding values of y are given in the table. Find the value of p. So for p, x is equals to 4, so simply substitute x is equals to 4 instead of p. So y is equals to 3 plus 2 x minus x square. Instead of x, substitute 4 and we'll get -5. So the value for p is simply -5. Part B, on a graph below, draw the graph of this equation. So I've already done that. Just plot the given points and then join them with a smooth curve. Next part is part C. Use the graph to find the value of y when x is -1.9. Value of y when x is -1.9. Let's first spot where x is -1.9. So it will be somewhere over here, -1.9. Yes. Now extend this line. Grab a scale and extend this line. So I've made a straight line. Now note where the two graphs are cutting each other. Mine are cutting at this point, which is roughly y is equals to -3.7, let's say. So this is my answer. Your answer would be a little different. So I believe the answer at the back is -4.4. The answer in the marking scheme is -4.4. So probably your lines will cut somewhere over here. Alright, for next part we have to find the value of x when y is -10. So going back to the graph, where is y equals -10? It's here. Make a straight line over here and see where it's cutting your x-axis. So it's cutting here and here. I'll go check these particular values. One is cutting somewhere over here if I extend this line, and the other one is cutting, let's say, over here. You're supposed to extend it with a scale and take an accurate measurement. So this is minus, let's say, 2.6, and this one is positive 4.6. Again, your answer will be slightly different. Check your answer from the back of answers given at the back of the worksheet. And then the last part is state the equation of line of symmetry of this graph. So the line of symmetry of this graph will be this line. The line of symmetry will be this line. So the equation of this line is, this is x is equals to 1. X is equals to 1 is the equation of line of symmetry. Question number 10. Complete the table for this given equation. We need the value of q. So for q, x is equals to 2. Simply substitute 2 instead of x. Put this value in your calculator and you will get minus 2. So q is equals to minus 2. Part B, on the graph below, draw the graph of this equation. I've already done that for you. Part C, state the minimum value of y and the value of x at which it occurs. So for this graph, I made a rough graph. We need a minimum value of y and a minimum value and the value of x for which it occurs. So the minimum value is minus 2.5 here, and the value of x is 3. So y is equals to minus 2.5 and x is equals to 3. Part D, by drawing a straight line on your graph, solve this given equation. Okay, so the given line is not a straight line. This line is not a straight line, whereas they're asking us to draw a straight line. So we need to change this into equation of a straight line. Now notice the left hand side is actually equals to y. So change this to y is equals to 4. Now we have a simple linear line or a straight line. Go back to the graph and draw the line y is equals to 4. Y is equals to 4 will be this line. And for this line, see where it's cutting your x-axis. So here, roughly somewhere over here and here. So my two answers are 6.6 and here I have minus 0.6 roughly, minus 0.6 or minus 0.5, something between these two. Question number 11, thankfully the last question of the worksheet. In the figure, this curve cuts the x-axis at 2 points and y-axis at point C. Find the coordinates of A and B. Find the coordinates of C. So notice that for C, let's find C first because it's easier. So I'm doing part B first. When the graph cuts the y-axis, the x coordinate is 0 and we need to find the other coordinate. So we also know the equation of the graph, which is y is equals to x square plus 3x minus 10. In this equation, substitute x is equals to 0 and we get y is equals to minus 10. So the value of C is simply minus 10. This is the answer for part A. For part B. For part A, again this is the equation. Now for point A and B, y coordinate is 0 and we need to find the value of the x coordinate. In fact, in the last part, in part B that we just did, the answer should be 0 comma minus 10, because they need the coordinate of point C, the whole coordinate. So you need to give the value of x and the value of y as well. Okay, question part A. We're doing part A now. Now the value of y is 0 because the points A and B are lying on the x-axis, and on the x-axis y is equals to 0. So y 0 is equals to x square plus 3x minus 10. This is the quadratic equation. We can solve it by by factorizing it. So the factors become 0 is equals to x square plus 5x minus 2x minus 10. X is common in the first two, x plus 5, then minus 2 is common and x plus 5 is equals to 0. I am directly writing both the answer. One answer is x equals to minus 5 and the other answer is x is equals to plus 2. So the coordinates of A will be minus 5 comma 0 and coordinates of B will be 2 comma 0. That's it. We're done with this topic.